first half, we learned about squares and rectangles. Now, this time we're going to have isosceles triangles, equilateral triangles, and semicircles, okay, that are formed from the bases. So, to find the three-dimensional volume, it's basically the base that we're using. So, if it's an isosceles triangle, the base is the diagonal that goes across. Well, from back in the days of geometry, we learned that in a 45-45-90 triangle, if the hypotenuse was y, each of the sides were y divided by the square root of 2. So this is the diagonal, or the hypotenuse. So each of the sides would be d over square root of 2. Well, find the area of a triangle, you take 1/2 the base times the height. So it's 1/2, this is a base, and this is a height, because that's where a right angle occurs. So if we multiply these, we get 1/2 times d squared over 2, or 1/4 d squared. So that's the formula we'll use for the area of an isosceles triangle, 1/4 d squared. For an equilateral triangle, you make two 30, 60, 90 triangles out of it. So this is d, okay? If this is 60, this part of it is half of d, so this is half of d times the square root of 3, or square root of 3 over 2d. And that arrow makes it really confusing, because half of d is right there. So let me get the red marker out. Boom, red. So this is square root of 3 over 2. Okay, square root of 3 over 2 is the height. Because if this is d all the way across, half the way across is 1/2 of d, and you take the short leg of a 30, 60, 90 times the square root of 3 to get the long leg. Okay, so 1/2 the base times the height is 1/2 of d times square root of 3 over 2d. So if you multiply it, it's square root of 3 over 4 d squared. Okay, this is 1/4 d squared. This is square root of 3 over 4 d squared. And a semicircle, okay, is half a circle. So pi r squared. And if d is all the way across this distance, then half of d would be the radius. So pi times the radius squared, pi times, and that's for a whole circle. So a semicircle is half of that. So it's 1/2 pi times 1/2 of d squared. So if you do the math, it's 1/8 pi d squared. Okay? So you got to know those three formulas, and then we get to the problems, and we refer back to that formula. So the base of a solid region bounded by an ellipse of 4x squared plus 9y squared equals 36. The cross sections are perpendicular to the y-axis and they're equilateral triangles. So you got an equilateral triangle like this. An equilateral triangle like this. It's even bigger. And then this one's the biggest one. And then these are the same size going down here. As they go up, they go down. So we're just going to go from 0 up to 2. From 0 up to 2. Because if this is -2, that's 2. Of this. And by doing that, we're going to find half of it and then just multiply by 2. Okay? So if we're perpendicular to the y-axis, we have to solve this for x. Okay? We're going to have to solve that equation for x. So if we solve this equation for x, and I'm pretty sure, yep. So we're going to take 4x squared equals 36 minus 9y squared. And then we're going to divide by 4. So x squared equals 9 minus 9/4 y squared. Okay, so then if we take the square root, x equals the square root of 9 minus 9/4 y squared. So these are going to be equilateral triangles. So I've got to put it into the equilateral triangle formula. And so that is going to be, okay, just a second. Oops. So if we take the square root of this, that's just the area from here to here. We also have to have the negative square root or multiply this by 2 to get this whole region, to get the whole region. So if we're going with an equilateral triangle, it's going to be the integral of the square root of 3 over 4 times 2 times the square root of 9 minus 9/4 y squared, and we're going to square that. And the integral is going to be from 0 up to 2. And then what I would do is I would square this out, 0 to 2, of square root of 3 over 4 times 4 times 9 minus 9/4 y squared. And these 4's cancel. So it's the integral from 0 to 2 of the square root of 3 times 9 minus 9/4 y squared. Then I'd grab my graphing calculator and let it do the magic here. Math 9 from 0 to 2 of the square root of 3 times 9 minus 9/4 y squared. And then obviously the calculator has to have x instead of y. They'll still give you the right answer. So this is 20.78, and that's just for from here to here going this way. Then we need the bottom half too, so we multiply by 2. So it's 41.56. Okay? So now if they're isosceles triangles, the only difference of what you do is 0 to 2. If they're isosceles right triangles, then you go 1/4 d squared, right? Yep, 1/4 d squared, 1/4 times 2 square root of 9 minus 9/4 y squared, and square it. Yep, you can put that into your calculator just that way instead of squaring it and doing that. Okay? If they're semicircles, it's 1/8 pi and then d squared. Okay? So basically they become graphing calculator problems. All right. So here's a triangle, and you're going to, cross sections are perpendicular to the x-axis, and they're semicircles. So they're little things here and getting bigger as they go this way. Okay? So it's going to be the integral from 0 to 1. You got to solve this equation for x because it's perpendicular to the x-axis. So solve it for x. Or solve it for y. So y equals 1 minus x. So it's going to be 1 minus x. And then if it's semicircles, it's 1/8 pi this squared. Okay? So if we do that, 1/8 pi that squared, math 9 from 0 to 1 of 1/8 pi times 1 minus x squared dx 0.13 what was it 0.131. Now if we would do this the other way, you should get pi over 24. If I go pi divided by 24, I bet it's the same answer. Okay. I looked on my sheet. But how do I know?
We just have to start guessing.
No.
Pi over 20.
No. So what you have to do is you actually integrate by hand. Or, actually, yeah. Well, let's just integrate by hand really quick here. So 1 to 0 of 1/8 pi times 1 minus 2x plus x squared. And 1/8 pi can go out front. And we integrate from 0 to 1 of 1 minus 2x plus x squared. And you could put that into your calculator, but we won't have to because it's x minus x squared plus 1/3 x cubed. And put in a 1, and you get 1 minus 1 plus 1/3. So it's 1/3 times this, which is this. Okay. I don't want to integrate by hand on the other two, but no. So that's the basics of what we're doing. It's just figuring out the integrals and plugging them into these three formulas. Okay. If it's an isosceles triangle, use that formula. Equilateral, that formula. Semicircle, that formula. Okay. So try to make your way through this. Oh yeah, we should definitely throw those on a note card.